Hi, today I'm going to talk to you about dynamic routing and give you an overview of that. This is a part of my advanced networking course. When we look at dynamic routing protocols, it's something that has been used since the late 1980s. And there are different versions and there are different types depending on what kind of network we have and what kind of protocol we would like to use. For instance, we have the older ones and the simple ones, which is RIP, for instance, and we have some more advanced ones, for instance, OSPF and ISIS. And many of them will also function with IP version 6, for instance. The whole idea here with using a routing protocol is to get the routers to update automatically with their neighbors about their different networks that they are directly connected to. So instead of using static routing, we will use dynamic routing instead, so that they will discover remote networks, they will maintain an up-to-date information about the different networks, they will choose the best path to the destination network, and it is also where we can used for finding a path when something goes wrong, so that we have a redundant way to the different networks. When we look at the protocols, well, there are different components. For instance, we have the data structures, which are, for instance, the tables and the databases they use to update their routing table. This is mainly kept in the RAM of the router. We have the routing protocol messages, the way that they find out about things. Do they send small hello packages? Do they send their entire routing protocol to their neighbors? There are different ways of handling this. And then we have the algorithm, which finds out the best path to different networks. So for instance here, when we look at EIGRP, which is one type of routing protocol, if you look at the data structures, it has a neighboring table and a topology table, and it uses these two tables to find out and to build their routing table. Then they have their messages, their routing protocol messages, which is in EIGRP, they send hello packets, update packets, queries, replies, and acknowledge. Small packages that are sent back and forward to between the different routers that use EIGRP. Then we have the algorithm in EIGRP. It's something called a dual. This is the way that EIGRP finds out what is the best path, what is the fastest way to get from one network to another. And other protocols have different types of structures and messages and algorithms. The advantages of dynamic routing is quite obvious, because instead of you as an administrator having to update all your routing, your static routing, here the routers will do it themselves. And also they will find out what is the best path, because for instance they will know the bandwidth of the different links between the different routers and thereby can decide which way to send the information. Also, if a route goes down, it will find a backup route to the destinations if it's possible. So it requires less administrative overhead, and it will also adjust and scale very well if something changes. The disadvantages is, of course, that it uses the router's both CPU for finding the best path and also the bandwidth of the different links between the routers, because it will have to send updates. Not all the time, but if something changes, it will have to send different updates. So it uses more of the router hardware than static routing, because static routing does not update anything. So if we look at the static routing and look at the advantages, well, it's easy to implement in small networks, but the disadvantage is that it is very difficult to implement in larger networks. And the destination is always the same. The updates will always be there. We have full control of what we have set up, because that is the only routes that are available, is the one that we have made ourselves. And it does not utilize anything of CPU or bandwidth in the routers. But of course, it is extremely it makes very difficult to administer if you have large networks. And of course, an advantage is also that it is very secure, because we have full control of what it is implemented. If you look at dynamic routing, it's something that you will use in larger network where you don't want to set everything up manually yourself. It's scalable, and it will adjust to changes in your network. And if something goes wrong, it will find a different route if possible. It's less secure, and it will take some of your router functionality, because it will use the CPU, it will use the bandwidth for updates. Yeah. So what happens when we start a router up and we implement a routing protocol is that it will start finding out and sending messages out of its routing interfaces, and see if I'm a RIP router, or if I implement myself with EIGRP, then I will start sending messages out on my different interfaces. And then it will start finding out if they have neighbors using the same routing protocol, which is of course something that is needed to be updated. And then it will start sending updates, and it will start receiving updates from its neighbors. And within a very short while, it will be updated with all the networks available. And also, if there is a change, the change will be updated out to the rest of the neighboring routers, and then step outwards, of course, also. So let's try to have a look at a very small setup here, where we have 3 different routers. And when we start them up, they will know their own directly connected networks. So the first router will know the network over here, 10.1.1.0 and 10.2.0.0, because they are directly connected. The router here will not know anything about the network over here, because it's not directly connected. So all the 3 routers will now know their directly connected networks. And in this case, this is a very simple routing protocol called RIP. And RIP will find the best path by looking at the hop counts. If the hop counts is set to 0, it means that they are directly connected. If the hop is set to 1, it's connected to a neighboring router. If it's set to 2, you have to jump to 2 routes, and 3 and 4 and so on. So it's just a number of how far away from you the different routes are. So in this case, when we start up, we only know about the directly connected networks. Then they start sending information to each other. So router 2 will send information to router 1 and router 3 that for instance, here, I know the network 10.3.0.0. It will send that to router 1, and router 1 will then update its routing table. Okay, see, I now also know the network called 10.3.0.0, and it is 1 hop away from me, because I have learned about this network from my neighbor, router 2, and router 2 had a hop count of 0, so it will just add 1 to what information we get from router 2, or my neighbor. We will also see that the exit interface here is 0, 0, 0, 0, or S000. So I will send the information out on this interface here. So I will know the direction. I will go out through my serial interface, and I will go 1 hop. Then I will reach this network. And we can also see here that router 2 gets also information from router 1 and router 3. So here it will know the network 10.1.0.0, which is this network over here, and I will go through my serial 0.0.0 interface, and I will hop once, because I need to go through router 1. So in this way, they all get information about their neighboring routers directly connected network. This is step 2. The next step is when I get the next update in. Well, then I also will know about, for instance, here, I will know about the different, oh, this is still the same. I think that this one here, now I will know about networks further away from me, because now this update here is going, for instance, about 10.4.0.0 has gone to router 2. Well, yeah, that was what happened before. And now this update will also be sent to router 3. So now this one also would know about 10.4.0.0. And again, it will go through my serial 000 interface, and I now have 2 hops because it's behind router number 3. And now all the updates has been sent, and we know what's available on the entire network here. So now we have what is called a convergence in the network. All routers know about all different networks that's available. And yeah, this here, the RIP protocol is an old protocol, and it's not very scalable, because if things get larger, it will take time before we have the convergence. Convergence means that all the networks are informed about all, or all the routers are informed about all the different networks. And that takes time when we are using RIP. And RIP also will send out their entire routing protocols, not only an update, but it will send the entire protocol or routing table out every time it sends out to an update to its neighbors. So achieving convergence is the time it takes to have all the updates sent out, and we are all agreeing on all the different networks that are available in all the different routers. Older protocols such as RIP, for instance, are slow in convergence, whereas modern protocols, OSPF, EIGRP, are faster on convergence. Convergence is also measured when we have our network set up, and when we want to change something. That could take longer time in RIP, for instance, than in OSPF. Yeah, and that was all about the different dynamic routing protocols, or an overview of it.